see screen? I hope all of you can see the screen. Hello. Okay, so all of you can see the screen. Okay. So in the last class, we are discussing about the assumptions of limit state method of collapse in flexure. Okay, so all of you please open your PDF IS 456 and go to clause number 38. I think it is in page number 68. Okay, so I hope and I think we have discussed these assumptions already in the last class. Is it? I think we have discussed these assumptions in the last class. Yes or no? Hello? In the last class, we have discussed these assumptions or not? If you can hear me, please respond. Okay. Yes or no?
Yes, sir.
Okay. Okay. All are discussed, I think, no? I think these assumptions have been already discussed. 1, 2, 3, 4, 5. Okay. So let us move to the next part. Okay. So this is the graph which I have explained in the last class, but this is the detailed explanation of the graph. Okay. Stress strain relationship for concrete. Okay. You can read it. For design purposes, the compressive strength of concrete in the structure is taken as 0.67 times of the characteristic strength. Okay, so I have told you this is the graph for the cube which we will make in the laboratory. That means for the 15 centimeter cube which we will make in the laboratory, and if you test the compressive strength of that cube, you will get this ideal curve. Okay, idealized curve for concrete in cube. It is written here. But if you this is for design purposes, the compressive strength of concrete in structure. I have told you in the last class, while you are constructing a structure, the strength is approximately a little bit reduced. So we assume that according to IS 456 that this strength will be reduced to 0.67 times of characteristic strength. Okay, so actual value was FCK. So, but for design purpose, it will be taken as 0.6 times of 0. FCK. That means your characteristic strength. Next, again, according to IS 456, we have to apply a partial safety factor. Okay, and for concrete, it is 1.5. So, if we have to divide this characteristic strength by can you hear my voice now? Hello. Okay. So this curve has been discussed in the last class, so I'm not going to discuss it again. But this is the detailed explanation. Okay. Here it is written the initial portion of the curve is parabolic. This portion. After a strain of 0.002, that means this value, the stress becomes constant. You can see here, if you draw a line here, that means at this point, beyond this 0.002, your stress will become constant. That means this along this axis, whatever value you will get at this point, it will remain constant up to this point. Okay, until a strain of 0.0035, your stress will remain constant, but your stress will remain constant, but your strain will goes on increasing. Okay, and after reaching 0.0035, your structure will be assumed to, here it is written, concrete is assumed to have failed. After achieving this amount of strain, your concrete will be failed. Okay, so this value is known as ultimate strain. Okay, this value is known as ultimate strain because after reaching this value, your concrete will be failed. Next, again, let us see the stress strain relationship for steel. Okay, here the stress strain curve for mild steel and Fe500 is shown in the figure. This is for mild steel and this is for Fe500. Right. And these figures are also given in your IS 456. Okay, these figures are also given in IS 456, so you can go through it. So what is the meaning of it? I think I told you in the last class. Again, you see the explanation here. For mild steel, the value of characteristic strength is taken as yield stress, and the design curve is obtained after applying a factor of safety. It is not factor of safety, it is known as partial safety factor of 1.15 to yield stress. Okay, that means the design stress for the steel will be, this is our yield stress divided by partial safety factor. So our design stress will be, if you divide this value 1 divided by 1.15, you will get 0.87 F1. For similarly for high strength bars, that means Fe 400 or 500, 415 or 500, the yield stress is taken as 0.2% of the proof stress and factor of safety is applied to it. So here, you can see here, design stress values for mild steel it is 0.87 Fy. For mild steel it is 250. So 0.87 into 250 to be this one. For Fe415, same formula, 0.87 into yield stress, which is 415. For Fe500, 0.87 into 500, so you will get this value. Okay, so these are our design strength or design stress values. Okay, design strength or design stress value for Fe mild steel, for Fe415 and Fe500. So this is the curve for mild steel. All of you please remember these graphs, okay, because in exam you might have to ask what is the shape of the curve, what is the value at this point, what is the value of this curve. These things you might get in exam. Okay, so you remember this graph. Similarly, this graph also. Okay, so now let us start our singly reinforced beam by limit state method. So this figure is also given in IS 456. This figure is also given in IS 456. All of you please go through the figure. I think all of you can hear my voice, all of you. Okay, this is the section of a singly reinforced beam. This is the strain diagram. This is the stress diagram. So our stress diagram will be this one. Why it is this one? Can anyone tell me why this is parabolic? This is straight. Can you tell me from where you have got this? Can anyone tell me why this graph is like this? This portion is parabolic. This portion is straight. Anyone have any idea? From where we have got this diagram like this. This portion is parabolic. This portion is straight. Anyone, any idea how we have got this diagram? Anyone? This is common. This is the common diagram for working stress limit state method, working stress method, same diagram for strain. But for stress, how we have got this diagram? Anyone have any idea? Please respond. Okay, yes sir, no sir. At least you say something. Okay, so see, this diagram is known as I have told you just now. This is stress diagram. So I was explaining about the stress diagram. This one. After reaching this point, our straight line portion. Straight. Okay, so this diagram is remember this. From here, it will start. Then it will be parabolic. At this point, it will become straight. Can you hear my voice now? Is it clear now? Can you hear me now? Can you hear me now? All of you? Okay, to Achumi? Okay, okay. Okay. So, okay. See, this is our focus diagram. Is explaining about the stress strain curve for steel as well. Okay. So, see, stress strain curve for yesterday, this because this is the so what shape of initial from it means at this point your stress is zero. That means this is our so is it cracking again? Is it clear now? Cracking, okay. Hello. Okay, we will meet at 10:15. Okay, because of this network issue, we can't continue at this moment. So we will meet again at 10:15. Okay, and you will get the attendance in the second class only, not now. All of you, you have to join in the second class, then only you will get the attendance. Okay, thank you.